This is section 3.2 on the chapter on exponents. Section 3.2 is basically an application of the rules. You have a copy of all of the different rules. I think there's 6 of them that we use, and it's just practicing utilizing them in form and in context. So the first question says, explain why 4 squared when multiplied by 5 is equal to 4 to the 10. And I think when we've done this quite a few times, that if it's in brackets, this is the base. 4 squared is the base. And we can think of it as either being 16 as the base, or we can think of it being 4 squared to the base. And the exponent outside the bracket says multiply the base by itself that many times. So really, what we're asked to do is take that base and multiply it by itself 5 times. Now, if we write it like that, that still looks a little confusing because we don't know what it says. But if we think about 4 squared as simply being 4 times 4, multiplied by another 4 times 4, multiplied by another 4 times 4, and multiplied by another 4 times 4, and multiplied by one final 4 times 4, it's right here that we can see that what we really have is a string of 4 being multiplied by itself 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's the reason why we use 4 to the exponent of 10. The second question, B, or 2, excuse me, says show whether the expression negative 2 squared multiplied by negative 2 cubed and the expression square brackets negative 2 squared exponent 3 are equal. So first of all, if we apply simply our rule, because we're multiplying powers that have the same base, the rule is keep your base and add your exponent. So if we did that, we'd have negative 2 as our base and 5 as our exponent. So when I simplify this, I would get negative 2 to the 5. And if I wanted to look at repeated multiplication, I could say negative 2 squared is that, multiplied by negative 2 cubed, which is that. And I'm really multiplying negative 2 by itself 5 times. However, here, our rule is when you have a power to an exponent, the rule is keep your base and multiply your exponents, in which case we would have negative 2 to the 6. And again, just like the last question, negative 2 squared would be this, multiplied by itself 3 times. We can clearly see that we have a string of negative 2 being multiplied by itself 6 times and not 5. And the last question, 3, it says explain why 3/4 when multiplied by itself 4 times, or to the power of 4, is equal to 81 over 256. 2 ways you can do it. You could apply the rule, which says when you have a fraction or a division statement to an exponent, you disperse the exponent to both the numerator and denominator. So that would be 3 to the 4 over 4 to the 4. 3 to the 4 in repeated multiplication is 3 times 3 times 3 times 3. 4 to the exponent of 4 is 4 times 4 times 4 times 4. 3 times 3 times 3 times 3 is 81. 4 times 4 times 4 times 4 is 256. So in standard form, we'd have that. Now, that's just using the rule. If I looked at it in repeated multiplication, it would be 3/4 multiplied by itself 4 times, which I would write out like this, which would then become this, which would then become this. Question 5. It says write each expression as a single pair, then evaluate each power. So I'm multiplying powers that have the same base. In this case, they both have the same base of 4. So the rule is keep the base and add your exponents. So as a single power, it'd be 4 to the exponent of 7. If you're going to evaluate it, you grab your calculator. Remember, we have our XY button up here, so that's important. Define your base as 4. Press your XY button. Press the 7 and press equals, and in standard form, you have 16,384. That's evaluating in standard form. The second one, you are multiplying like bases with different exponents. So you add the exponents to get 7 to the power of 6. Calculator, 7xy6 equals 117,649. And finally, keep the base because it's defined with brackets. Add your exponents. Now right here, I know that as a power, it's a negative base with an odd exponent. So I know definitively my standard form will be negative because when you have a negative base to an odd exponent, you will always end up with a negative standard form. If I grab my calculator and go negative 3 as the base, exponent of 7 equals negative 2,187, right? If this was an even number, that would have been positive if it was even. Question 7 says write each expression as a product. Write each expression as a product of two powers. So there's your first power and there's your second power. So your first power is 4 multiplied by itself 3 times. Your second power is 4 multiplied by itself 4 times. So therefore, as a product of two powers, it would be that. And as a single power, you would keep your base and add your exponents to get, as a single power, 4 to the exponent of 7. P, you have 2 to the exponent of 5 multiplied by 2 to the exponent of 2. Keep your base and add your exponents. You get 2 to the exponent of 7. And finally, C, you have 1, 2, 3, 4, 4 nines. So you have 9 to the exponent of 4 being multiplied by 9 to the exponent of 7. Keep your base and add your exponents. You get 9 to the exponent of 11. Did anyone else get the Lion King there? What is it? 9. Just me? I'm the only one. 9 to get to the exponent of 11. Da, da, da. Question 8. Write the following expression in repeated multiplication form and then as a single power. So, repeated multiplication would be 3 times 3 for this one, multiplied by 3 times 3 times 3 for that one, multiplied by 3 times 3 times 3 times 3 for this one. How many 3's are being multiplied together? There are 2, 5, 9. So as a single power, it's 3 being multiplied by itself 9 times. An easier way would have been just keep the base and add your exponents. You would have got the same answer without having to write it in repeated multiplication. Question 9, write each expression as a single power, then evaluate. So because I'm dividing like bases, they both have the same basis, keep the base, subtract your exponents, which will be 5 squared, which in standard form is 25. Next one, subtract your exponents, get 3 to the 4. 3 to the 4 in standard form is 81. And the last one, keep your base. Remember, if it's defined with brackets, it is the base. Subtract your exponents. You get negative 4 in brackets to the exponent of 4, which is 16 times 16, which is 256. Question 11, write each expression as the quotient. So Toby, quotient is the fancy word for what? That's right, answer to a division. Well done. So write it as a quotient of two powers, and then it's a single power. So A would be 6 to the exponent of 4 divided by 6 to the exponent of 3, which, since you're dividing like powers, you subtract your exponents, and you get 6 to the 1, which in standard form is simply 6. The second one, B, you get 3 to the exponent of 8 divided by 3 to the exponent of 2, which would be 3 to the exponent of 8 minus 2, which would be 3 to the exponent of 6, which is a big number, 81 times 9. 81 times 9 is 729. Did I do that in my head? Wouldn't that be amazing? Wouldn't you all be amazed if I did that in my head? I think I'm wrong. Oh, it is right. Look at that. Mic drop. And finally, C, we have 1, 2, 3, 4, 5, 6, 7. 5 to the exponent of 7 divided by 5 to the exponent of 1. Keep your base and subtract your exponents to give you 5 to the exponent of 6, which is 25 times 25. I can't do that in my head. I'm not that smart. Oh, that's the wrong base. 5 to the exponent of 6 is 15,625 in standard form. Next question. Write the following expression as division of two powers. So we know that we're subtracting the exponents, which means we would have had our base, this one, and we would have been dividing it by this. In order for me to get this step right here, I would have had to have originally this question, keep the base and subtract your exponents. So that's the answer it's looking for. What is the division statement? It's 5 to the exponent of 7 divided by negative 5 to the exponent of 2, excuse me. Question 14, write 3 squared to the power of 4 as a single power and evaluate. So write it as a single power when having a power to a power. The rule is keep the base and multiply your exponents, which would be 3 to the exponent of 8. Keep your base, press your XY button, press the 8, press the equals button. 6561 is your standard form. The next one. Ooh, this is interesting. So for B, we have the product of two numbers in brackets. And the reason why it looks different than a lot of the other ones is because we have square brackets. But the rule is when you have the product of numbers in brackets to an exponent, you are to disperse the exponent to all of the terms of the product. Now, it does not work for addition and it does not work for subtraction. It only works for division and multiplication. So this would become This would become 7 to the exponent of 4 multiplied by negative 3 to the exponent of 4, which would be 7 to the 4th is 2401, multiplied by negative 3 to the 4th, which we already know is 81 because we did it already. And we take our calculator, take that number. What's that? I can't do that in my head. What do you think I am? I can't do it. Too smart. 194,481. All right, and finally the last one, C, says write 5/6 as the quotient of two powers. So here we have a fraction to an exponent of 4. We can also think of it as being this question. And when you have this question here with multiplication of two numbers in brackets, we disperse the exponent equally. Here you would do the same thing. You would put 5 to the 4th divided by 6 to the 4th. But because it's in fraction form, which is the same thing as division, we're going to do the same thing. We're going to disperse the exponent of 4 to the numerator and to the denominator. We're then going to evaluate both. 5 to the exponent of 4 is 625. 6 to the exponent of 4 is 36 squared, which I have no idea what it is. 1,296. And that's what you would get in standard form. I wonder if that's lowest terms. Yep. 625 is only divisible by, I think, by 5. And 1296 is not. Question 15a says write this as with one exponent. Oh, this is interesting. Now, this number here, negative 4 squared, is in brackets. This is not the same thing as this number. I want you to think about that for a second. The brackets are around there, and I don't know why the brackets are even here because you don't really need them. The brackets are there, I think. Oh, I know why they're there. They're there to separate the 3, right? So this is not the same thing as this. So here's what you would do. When you have a 3 here, this says the opposite of 4 squared cubed. The opposite of 4 squared cubed. So when I write it out as one exponent, I must keep the negative 4 not as my base, but like this, which will be negative 4 to the exponent of 6. And I could put brackets around it if I want, but I don't need them. So this is even though it looks like it's going to be an even number because, or a positive standard form because your exponent is even and your base appears to be negative, this is not a negative base, and your answer will be negative, and it would be negative in standard form. I'm going to take 4 to the 6 for exponent 6, 4096, and it would still be negative 4096. And you could put brackets around the whole thing here. That does not change the fact that it still says the opposite of 4 to the 6. Okay, if the exponent is outside the brackets, it's used in repeated multiplication. If the exponent is inside the brackets with this, it's interpreted as the opposite of 4 squared. That one on a test would get 90% of the students wrong, maybe, perhaps. Easy to get wrong. Question B says write 3 times 4 to the 4th as a multiplication of 2 powers. So again, when you have a multiplication of numbers by an exponent, you can disperse the exponent to each part inside the brackets. So you would have those two, which would be 81 multiplied by 256, which will be 81 multiplied by 256 equals 20,736 in standard form. And finally, C, 4 fifths in brackets cubed. You may disperse the exponent of 3 to both numerator and denominator. You would get 1664. Feels like we did this one already. Over 125, which is lowest terms. All right, question 17 says copy and complete the table. So for A, we have an exponent of 3 outside the brackets, which means we can apply it to both the terms in the product, which means it's going to be 2 cubed multiplied by, in brackets, negative 5 cubed. In repeated multiplication, that would be 2 times 2 times 2 multiplied by negative 5 times negative 5 times negative 5. I guess this is the powers first. I did it backwards. I did powers first and repeated multiplication second. In the second one, it says 9 times 8 times 9 times 8. So if we had 9 times 8 in brackets and had an exponent of 2, that's what it would look like in repeated multiplication. So for this one, that is what it is for B. And for C, in repeated multiplication, this would be 2 over 3 multiplied by 2 over 3 multiplied by 2 over 3 multiplied by 2 over 3, or 2 to the exponent of 4 over 3 to the exponent of 4. Question 18, evaluate 2 to the power of 0. Use a pattern to justify your answer. So if I took any number of 2 and I put any exponent, doesn't matter what it is, I'm going to keep it simple and use 3. And I was to divide it by the same power of 2 with the same exponent of 3. If you used your rule of division of like powers with different bases, you would keep the base stack and you would subtract the exponents to give you an exponential form of 2 to the 0. But if I was to translate this to standard form, 2 cubed is 8 divided by itself. Any number, when you divide it by itself, will have a standard form of 1, which therefore means that those two would have an answer of 1. Question 19 says evaluate negative 4 to the exponent of 0. So this one is not negative 4 to the exponent of 0. I shouldn't have read it that way. This is the opposite of 4 to the 0. The opposite of 4 to the 0. Since 4 to the 0 we've already talked about is going to be 1, then this will have a standard form of negative 1. It's the opposite of 4 to the 0. And finally, the last one, if you keep your base and add your exponents, the standard form will be negative 4 to the 0, which is going to have a standard form of 1, because this time your base is defined with the brackets, which is different than when it's not defined without the brackets. Is this the last question? Question 21 says express each of the following as a single power. So if I was thinking this is a BEDMAS question, there's 3 squared to the 4 multiplied by 3 to the 3. I would do my exponents first, which would be 3 and 2 times 4, which would be 3 to the 8 multiplied by 3 to the 3. My next step would be to keep my power and add my exponents. Give me 3 to the 11 as a standard form. This is 3 to the 8 multiplied by 3 to the 3. Keep your base, add your exponents, you get 3 to the 11. When's the last fun? You are multiplying these powers here in the numerator. So keep your base and add your exponents to give you negative 4 in brackets to the exponent of 6 divided by negative 4 to the 3. Your last step would be to keep your base and subtract your exponents when dividing to give you a standard form of negative 4 to the 3.